Hey everyone, welcome to the webinar. And today we'll be covering how you can build highly scalable serverless applications with Amazon Aurora Serverless and the Amazon RDS Data API. I'll be covering most of the presentation today, and my name is Nitesh. I'm a product manager for RDS, and I build features for both RDS and Aurora engines. I also have with me Arvind, who'll be helping me with the Q&A portion of this. So please save your questions towards the end when we reach the Q&A section. And today's agenda, before we jump into it, is number one, an overview of our Amazon RDS or relational database service. Next, we will jump into what is Amazon Aurora Serverless for those of you who are not familiar with it. Then we will cover RDS Data API and what it means for you when you're building your serverless applications. Then we will do a demo and then close it out. So before I talk about the Amazon RDS service, just want to take a few minutes for you guys to just get an idea of how many people have used RDS, serverless, and data API. So there's a quick link in the webinar here for a quick poll. Just going to take a minute so that you guys can just review that and reply with your responses on how much you know about data API or serverless for that. All right. So it seems like we are already getting a few responses here. So again, just trying to get a feel for the room here and try to understand how many people have used RDS, Aurora Serverless, and Data API. And it's fine if you haven't, but right, gonna give it a few more seconds here for everyone else here to respond. All right. So what is Amazon Relational Database Service? So for those who are not familiar with RDS is all about choice. It's an AWS service which offers a fully managed open source and commercial database offering. So in the open source space, we offer PostgreSQL, MySQL, and MariaDB. In the commercial engine space, we offer SQL Server and Oracle. And these are the engines that our customers told us they wanted, and that's how we supported them. And lastly, we added Amazon Aurora, which is our own homegrown cloud native MySQL and PostgreSQL compatible database. And what this means is it's a database built for your cloud and native with MySQL and PostgreSQL support. So RDS is a fully managed platform. It provides automated failover. It also gives you capabilities such as automated backup and recovery. You get managed replication out of the box. It has industry compliance for security and isolation, and also managed patching and maintenance. So now, why did we create Amazon Aurora? And that's because the simple answer is because our customers told us they wanted it. So what customers asked for was a cost-effective enterprise-grade database at the price of open source alternatives and delivered it to you as a managed service. So Amazon Aurora gives you the speed and availability of high-end commercial databases. We also give you the simplicity and cost-effectiveness of open source databases, and it's plug-in compatible with MySQL and PostgreSQL, and it's a simple pay-as-you-go pricing, so you don't need to manage any infrastructure on your own. So why did we create Aurora Serverless now? And that's because there is a shift in the environment today towards serverless architecture. And why is that? Well, that's because right now, most people are writing these serverless functions, which are spiky in nature. These workloads spike up and down. And here are a few examples of some of the workloads that we pulled from our production fleet. And what we see here is the usage from our users is actually irregular. The database is in fact doing nothing most of the time. So if this database was provisioned for its peak workload, then the area under the curve only constitutes a small fraction of the provisioned resources. So for example, if you're a gaming company and a lot of people are using your games during peak hours, then yeah, it's spiking, but then eventually it dies down throughout the day. Similarly, for an e-commerce workload, which is our top right corner, you can see the traffic spikes suddenly to a really high transaction count and then drops almost overnight. to a pretty low transaction count. So what this would mean is you would have to provision for peak versus the area under the curve. So what this means for you again is you have to make some choices. And these are some decisions that all our customers are faced with when provisioning your database fleet. So first of all, you need to decide whether you need to provision for peak. But then this is expensive. You make the obvious choice and provision for your peak workload, and it's pretty much the industry standard thing to do for any workload that you care about. But again, this might potentially be expensive because now you're running large RDS or Aurora databases without it being idle or without it being used for most of the time. Second, you not only consider your daily peak, but you also forecast into the future and consider what your peak might be months or even years down the road. Because again, you want room to grow. So what this means is, again, you can't provision less than peak because then you won't be ready when that peak traffic suddenly hits. So it's not really a viable option because it impacts your customers and your application. So what you're left with eventually is creating infrastructure to continuously monitor and scale your database fleet and then optimize for cost. But again, doing this introduces more cost because now you're scaling a database fleet up or down, which by itself is a complex and risky operation. It often involves custom application layer logic or standing up a proxy layer to ensure no downtime during database cutover. And that's why we created Aurora Serverless. It's exactly the use case that Aurora Serverless is designed to solve, which is not provision for peak, but something that scales up and down with load. So again, here we have a warm pool of instances that we manage for you, and we automatically scale capacity up and down based on the workload that's coming in. There is literally no application impact when scaling, and you only pay for what you use. So you don't need to provision for peak or provision for less than peak. You only provision for what you need, and you pay per second with a 1 minute minimum. So with that, I'm going to show you a brief example of what that workload would look like. So here in the yellow, we have transactions coming in from the application, and in blue, we have our Aurora capacity units scaling up and down based on the load. So eventually, as you saw in the first few seconds, as traffic comes in, our Aurora capacity units scale up rapidly, and it reaches a peak here at 64 capacity units. And then eventually, when the workload drops, we scale down gradually because again, we don't know if the workload is going to spike again. So we don't want to scale down completely to zero. We scale down gradually in case the workload spikes again. So you don't need to worry about any downtime or any application or any negative application impact. So in summary, Aurora Serverless is a fully managed offering. You don't need to manage any instances. You don't need to manage a warm pool of multiple instances that you need to scale up and down. You don't even need to pick any availability zones. There is no migration between instance type generations. No need to upgrade to minor or major versions. Encryption is always enabled by default. You don't need to start and stop instances, and there are no database maintenance windows. These are only a few of the benefits that you see from serverless. But again, the biggest benefit still remains as cost, right? You're not provisioning for peak or under provisioning. You're not being able to handle your peak. And here are some of the newer features that we have launched in the last few weeks and months. The first one I do want to cover that's top of mind of all customers is compliance, audit, and security. We have been listening to our customers and working hard to add more and more industry and compliance certifications to Aurora Serverless, bringing in line with our other Aurora engines, which we call the Aurora Provision engines. And we've already added a few certifications here, such as FedRAMP, HIPAA, and so on. And some of the other mentionable features to note here is the addition of audit log support. And these are logs that are published directly to your CloudWatch log, so you can see who's logging into your database, what's happening. We also added SSL support, which allows secure communication with your database. We've also expanded Aurora Serverless to new regions. Again, these regions are the ones that customers are telling us they want, and we are obviously constantly evaluating which regions to expand our reach to. We've also added engine support for PostgreSQL 10.7. This is, again, a big feature that our customers were asking for, and we already started off with MySQL 5.6. And we are constantly adding support for new engines and new versions as we continue to scale up. And lastly, what I will be touching about more in detail is the RDS 8 API, which again lets you access your serverless database without needing to access your VPC or any JDBC driver. We've also added some other features such as cross-region snapshot sharing the query editor, which is available from the console, and a query metadata service. And with that, let me jump straight into RDS Data API. So we're really excited about RDS Data API. And before I go into what it does and how you can build your scalable applications, why did we create the Data API? Well, the use case that we heard from our customers is that the current database protocol is not optimized for your serverless needs. And there are four primary reasons for that. First, network topology. Currently, if you want to access your serverless cluster, you need to set up network topology to make sure your apps can talk to your database. So there's always that additional cold start delay every time you access your database. Second, there is a database connection limit. Relational databases traditionally have a limit to the number of connections you can support. And customers will sometimes run out of these connections because the current paradigm assumes long running connections. And what makes this worse is customers that are using Lambda functions, which is a very common use case to keep these connections, need to make sure that the Lambda function has finished executing. So you need to manage those connections and write code to open and terminate connections. And lastly, short-lived connections. In the current connection-oriented model that most of our customers are telling us, connections don't live that long. They are only working for a few seconds to a few minutes. And for that use case, serverless functions are a great fit, and Data API aims to solve these very problems. And with that, let me show you what this looks like. So Data API provides a simple public-facing secure endpoint that is addressable anywhere. The API sits between your application and your DB cluster, and this provides a few key benefits in contrast to your JDBC approach. First, you get to build stateless apps. A lot of customers want to build applications using microservices, serverless applications, or IoT-based apps on RDS, and they were relying on JDBC to do this. But now with Data API, well, you can take care of long-lived connections, and you don't have to worry about that. And this lends itself very well to the applications that you need to write. You also don't need to write any undifferentiated boilerplate code. So our developers said that they don't really want to write any boilerplate code. They don't need to manage. They don't want to manage connections, spool those connections, and Data API provides all these features out of the box. So what this means for you and your organization is it frees up your time to do what you do best, which is build killer apps on AWS. And lastly, Data API greatly improves application agility because you're no longer writing any platform-specific ODBC drivers, and our secure endpoint lets you access your database from virtually anywhere. So this means you can get up and running in minutes, and you can build applications in Lambda or use our Cloud9 IDE or use any of it to leverage our AWS SDKs. You never even have to leave your browser if you want to, or you can use your choice of offline IDE for any sort of app development to suit your needs. So let me show you what Data API infrastructure looks like. And here's a quick look under the hood of the Data API and why it's optimized for your serverless applications. So number one, Data API lets you connect to your database using any stateless application. You can use our endpoint and simply send an HTTPS request along with your SQL statements. All connections are encrypted end-to-end, and you can use IAM-based authorization for the API. And what this does is it lets you use fine-grained permissions to restrict access to your resources. You also don't need to configure any DB credentials because the API will fetch your credentials. And these are all stored in secret managers for easy access if you need to revisit these credentials or rotate them if you want them. So Data API also does connection pooling on your behalf. And what this means is that we open and manage database connections for you. And you can connect multiple Lambda functions, sending multiple queries or requests to your database. And lastly, our infrastructure, as you can see here, is it's split up into multiple availability zones. So it's optimized to handle the high throughput of your IoT devices or microservices-based application. Customer requests are load bounced across a variety of API hosts, and these are again spread across multiple availability zones so that you can access your Aurora Serverless cluster from virtually anywhere, and you have high throughput to connect and handle that traffic coming from your application. Next, the Data API also powers the console query editor that I spoke about earlier when referring to Aurora Serverless. So what this means is you can directly access your cluster or your database from the console, and you don't need to leave your browser. So you don't need to manage any client applications or create your own terminal. You can literally go to your RDS console, type in any queries you want, connect to your database, and execute them right there. So this makes it super easy for you to get up and running. So in summary, Data API gives you more of what you want and less of what you don't. Again, like I said, traditional JDBC connections, which are long-lived, are not ideal for your serverless applications. And Data API simplifies this paradigm and provides a few key benefits. The biggest benefit is we do a lot of heavy lifting, so you don't have to write any boilerplate code to do connection pooling, authentication management, or parameter management. It is all done for you out of the box, and you don't have to worry about the concept of connections, and you can easily send multiple requests or batch these requests to the Data API. We also give you end-to-end encryption with SSL to your database, along with CloudTrail auditing, so you can go in and kind of understand what's happening on your database. And lastly, IAM policies lets you restrict who can access the Data API and what they can pass in as request parameters. And these are all the features that our customers told us they want, and we are constantly making more changes to Data API to support your needs. So with that out of the way, I want to move to the exciting part of the presentation, which is the demo. So in this demo, before I jump into it, here's what I'll be covering. I'll be setting up a new Aurora Serverless cluster. I'll be using Lambda to connect to this cluster and writing a simple code to handle a push notification coming in from the Amazon SNS service. And then we will navigate to the SNS service to send a push notification to the Data API, which will then be added to the Aurora Serverless cluster. So with that, let's just jump right into the demo. So here, I've already created an Aurora MySQL serverless cluster. I've named it NY-DEMO-DB, and I haven't enabled the Data API. I do want to add that if you are creating a new serverless cluster, Data API is an option that you can enable directly when creating the cluster, or you can use CloudFormation to enable Data API when you're creating a new cluster. So I'm going to start the demo here. And yeah, so we have a serverless cluster here. It's in Aurora MySQL. And I'm simply going to select this database, and I'm going to click modify because Data API wasn't enabled. And then it's going to come up here. And then, yeah, I already set it up. The minimum Aurora capacity unit is 1. And I've set the maximum Aurora capacity unit at 64. Again, these Aurora capacity units basically let you scale up and down based on how much traffic you're getting into your database. We recommend setting a minimum of 1 so your cluster doesn't go to sleep, and you can easily scale up from, and you have a warm pool of Aurora serverless clusters constantly running, so you don't have to worry about any cold start issues. Next, I already have the Data API enabled here. Like you can see, it's just a simple checkbox, and once you enable that, you can directly use the query editor and start running your queries using Lambda or our Cloud9 IDE. So here I enabled the API, and then I'm going to go down and just save it. Well, I don't need to because I already have enabled it. And one of the things that you need to enable, or the identifiers that you need to connect your database, is the ARN, or the Amazon resource number for the database. So here you can see the ARN ends in NY-DEMO-DB, and this is important because you need references later. So now that the serverless cluster is created, I'm going to connect to it. So I'm going to select my database. I created some temporary credentials here, and I'm going to leave this blank. I'm going to just connect directly to the temp table right now. So here's the default query that comes up, and I'm just going to run this to make sure everything is working as intended. It's executing, and there you go. So it's that easy. I didn't have to set up anything. I can just click Data API enable, run a query from the query editor, and everything works. Now, the credential that I created earlier is saved in Secrets Manager. So here I'm navigating to my secret in Secrets Manager. Again, like I said, you can rotate these credentials if you need, but for now, I'm just gonna take my credentials for access later. Next, I'm gonna go to my Cloud9 IDE. So the Cloud9 IDE is an IDE that you can access directly using the browser. It's something pretty impressive because you don't need to configure your own IDE or worry about any offline IDEs. You can directly go to Cloud9 and drop your code, and you're good to go. And it integrates very well with other AWS services. One of the requirements of running your Cloud9 IDE before you can access Data API is number one, you need to give the right permissions to Secrets Manager and the Data API. And what this means is you need to specify the ARN of your cluster that I alluded to earlier, and also get your secret ARN, which is the secret that you will use to access this database. You also need to ensure you have Boto3 installed. And you can do this directly from the Cloud9 shell by typing in pip install Boto3, pretty standard command here. And here you can see the code that I wrote for my application. So you can notice that I'm not worrying about opening connections, closing connections. All I needed was my cluster and secret ID, and that's all I needed to get started here. The code is pretty short. It's only a few lines, and there's no boilerplate code that you need to write to access the database. And once I've done that, the function is live. So let's go to our credentials that I need to manage in IAM. So here you can see Cloud9 already creates credentials for you. And all I really did was add the Amazon RDS data full access role. So what this means is this role was the Lambda basic execution role was already created for me, but the data API needs full access. And that's why I granted this additional IAM policy here. And with that, I'm going to move next to Lambda and see what my function looks like. So this is, again, the function that I deployed using the Cloud9 IDE. It's already deployed for me. I'm going to select it. And all I want to make sure is that I have the right connections to SNS. And all I did was add a trigger by clicking add trigger and connected SNS. Again, no default configuration, no changes here, just adding SNS. And the code and the applications and everything was already set up for me by deploying it through Cloud9. And now I'm going to navigate to the SNS. And I created a special temporary topic here, called it NY demo topic. And I'm going to click on publish message. I'm going to leave all these fields blank. Again, just going to use the default body. And then I'm going to type in a message. JDBC is good. And then I'm just going to publish this message. And there you go. So we have the end-to-end thing working. The message is published to the data API and into your serverless cluster. I'm going to publish another message here just for the fun of it. Again, no changes, but data API is even better. I'm going to scroll down here and publish this message. And there you go. I published two messages here, and they're both in my serverless cluster through the data API. So let's make sure that these changes actually made it to my database. So I'm going to select this database now. And this database was created programmatically through my Cloud9 IDE code that I showed you earlier. It's called SampleDB. Again, the credentials stay the same. And I call this table sample table. So I'm going to clear out the query editor and just write a simple select statement so I can see what my messages were from the SNS service. So I'm going to select star from sample table and run, and it should pull up two messages. And there you go. JDBC is good, and data API is even better. And that's kind of the end-to-end demo. And then finally, I'm going to delete these messages to wrap up the demo here. And delete from sample table and execute that. And there you go. The rows were updated, and that kind of wraps up the end-to-end demo. So again, just to recap, I showed you how to create a new Aurora Serverless cluster and then enable data API. I used the ARN for my database and the ARN for my secrets manager that was used to access the data API, and used that to write a pretty short brief code using my Cloud9 IDE, and I published that function to Lambda. I used Lambda to add a trigger to my SNS service. I made sure I gave the right credentials to my database using IAM so that the Lambda could publish those messages. And then I used SNS topic to publish two simple messages that were posted to my serverless cluster. And then I used the query editor, kind of query that and delete that. That's kind of an end-to-end application demo for you. So here are a few resources that you can use to use the Amazon RDS Data API. First of all, here's the documentation for Aurora Serverless, some documentation for RDS Data API. If you want to screenshot this, I think this would be a good time to do it. A tutorial that I just covered, it's called the 10-minute tutorial, but as I did it, it only takes really 5 to do it. And yeah, that link is right there. And we would absolutely love to hear from you guys. So if you have any problems or concerns or questions about the Data API, if you have any issues or bugs, definitely send us our way. And that email is rds-data-api-feedback@amazon.com. I do want to mention that Data API went GA or generally available only this year, so we are only getting started. We want to keep delighting our customers with more features in the future, and we want to make sure we are meeting your needs. So if you have a special use case or you're trying to do something interesting and Data API is not working for you, do let us know what we can do to improve here. And with that, I want to open it up to Q&A, and I also have Arvind with me to talk to you through that.